Okay, so let's have a look at this limiting reagent type question. Okay, now as you read this question, we first need to work out what we've been asked to solve and what's the information that's been provided to us. So as I'm reading this question, I can see that we're being asked to work out the grams of iron. Okay, so at the end of my answer, I should have an answer in grams. All right, if I have an answer that involves moles or molecular weight, something has gone wrong. Can be produced from 6 grams of aluminium and 4 grams of iron oxide. Okay, so my initial thoughts here are this is a C-type problem, meaning that I've been given the mass of something, in this case the mass of aluminium and iron oxide, and I'm being asked to work out the mass of something else. Now, what gives this away as a limiting reagent or limiting reaction type problem is that I've been given the mass of two different things. Right? I've been given the mass of aluminium and the mass of iron oxide. Now, that's a bit of a problem because how do I know which of these two masses I should use to work out the answer to the question? How many grams of iron will be produced? Because I can guarantee you that if you base all of your calculations on, for example, the mass of aluminium, which is 6 grams, you're going to get one answer. And if you work out the grams of iron that will be produced from 4 grams of iron oxide, you're going to get a very different answer. So the first thing we need to figure out before we can really get into the C-type problem is which of these two values, either the 4 grams of aluminium or the 4 grams of iron oxide, are we going to use? And the answer to that is you use the limiting reagent. You use the chemical, the compound that is going to be used up entirely as part of this reaction, i.e. the chemical or the compound that is not in excess. And I'll have a look, or rather we'll have a look, and I'll explain what that means in just a second. So we've determined that this is a limiting reagent or limiting reaction type problem because we've been given two masses. And now the question is, how do we work out which is the limiting reagent? So the first thing I'm going to do here, and this is what you should do in almost any stoichiometric problem where you're given any information, is to work out the number of moles that you can. Right? This should always be your starting point. Work out the moles of whatever you can, and usually the rest of the problem will flow from there. So let's work out the moles of aluminium to start off with. And then we'll take a look at the moles of iron oxide. So, famous equation, moles is equal to mass divided by molecular weight. Therefore, my moles of aluminium is going to be equal to the mass of aluminium, which I'm taking from the question stem here, 6 grams divided by the molecular weight of aluminium. And I'm going to use a value of 27 to make my life easier, because technically it's 26.982, I believe, something like that. So we'll just use 27 to make life easier for ourselves. And we're going to get a final answer of 0.22 moles. It's actually 2 recurring, so I'll just leave it at 0.22. All right, that's not very helpful by itself at the moment, okay, because I don't know if I should be using this value or if I should be using the moles of iron oxide, which we're going to work out now. So I'll do this in a slightly different color. Let's do this color. So moles of iron oxide. Okay, again, exact same formula. Moles is equal to mass divided by the molecular weight. Therefore, the number of moles is equal to the mass of iron oxide, which is 4 grams, divided by the molecular weight. Now, for this one, I'm going to use 56 for the molecular weight of iron, and then I'm going to use 16 for the molecular weight of oxygen, which will give us a total molecular weight of 160 grams per mole. So at this point, it's simply going to be 4 divided by 160, which is going to come out as 0.025 moles of iron oxide. Okay, now at this point, I still don't know if I should be using this value as my number of moles, okay, to work out the moles of iron, or if I should be using the moles of aluminium. I've worked out 2 moles, but I don't know which one to use. And as you can see, you're going to get a very, very different answer depending on which one you use. So this is where we have to figure out, okay, what is the limiting reagent? I'm going to do this in one step, okay? And hopefully if I explain this well enough, you'll be able to do the same without having to go through a couple of extra stages here. So I'm just going to arbitrarily pick the number of moles of aluminium. Do this in green. I want to know, is this, the number of moles of aluminium here, okay, is this in excess, or rather, is this the limiting reagent, or is this in excess? So, how am I going to do that? Well, I'm simply going to convert the number of moles of iron oxide into the moles of aluminium. In other words, and we've done this before, this is kind of an A-type problem here. If you know the moles of iron oxide and you have a balanced chemical equation, you should be able to convert that number of moles into the moles of anything else. So in this case, I want to know, okay, if I have 0.025 moles of iron oxide, how many moles of aluminium am I going to need to react with that number of moles? And why am I talking about aluminium? Because if you see right back here at the beginning of the reaction, iron oxide reacts with aluminium, okay? So the question is, if I have 0.025 moles of iron oxide, how many moles of aluminium is that going to correspond to? So, again, this is an A-type problem. So our molar ratio, I'll do this in green as well, molar ratio between aluminium and iron oxide is 2 to 1. How do I know that? Because I'm looking at my balanced equation. I have a coefficient of 2 here and a coefficient of 1 here. Okay, so it's 2 to 1. So in order to work out my moles of aluminium, I'm simply going to take the number of moles of iron oxide. I'm going to times it by my conversion factor, which is going to be 2 over 1, because I'm trying to find out the moles of aluminium. Okay, so that's why the 2 needs to be on top there, and I get 0.05 moles of aluminium. Okay, why is this important? Well, all we need to do is look at this number here, 0.05 moles, and compare it to this, 0.22. So, in order to react with 0.025 moles of iron oxide, that's how many moles of iron oxide I have in my reaction mixture, I only need 0.05 moles of aluminium. Well, I actually have in my reaction mixture 0.22 moles of aluminium. So I have way more aluminium than I actually need. In other words, aluminium is not going to be used up as part of this reaction mixture. There's going to be some left over at the end because I have so much. So in other words, this is our reagent, which essentially is in excess. Okay, in other words, as far as this problem is concerned, I couldn't really care less about aluminium because it's the excess reagent. It is not the limiting reagent, so I don't really care for it. If that's the excess reagent, it must then mean that our iron oxide, is our limiting reagent. Why is that important? The rest of this problem, which won't take very long now, is going to depend on the number of moles of iron oxide. Okay, so actually just to kind of demonstrate this, let's get rid of all this because this is a little bit irrelevant right now. We don't care about the moles of aluminium. We've just said it's a reagent that's in excess, so it really has nothing to do with the rest of this problem. So we know the number of moles of iron oxide that we start off with. It's 0.025 moles. The question is asking us how many grams of iron do we need. So at this point, I'm just focusing on iron oxide. Aluminium is completely irrelevant. This has now become a B-type problem. Why is it a B-type problem? Because I have the number of moles, right, which is 0.025, and I'm being asked to work out the mass of iron. Okay, so what we're going to do here, we take the moles of iron oxide, 0.025. Before I can work out the mass of iron that's produced, this is kind of my end goal here, work out the mass of this, I need to know the moles. Well, I can do that because I have a balanced chemical equation, and I know that the moles of iron oxide is 0.025. So looking at this equation here, the molar ratio between iron and iron oxide is 2 to 1. Molar ratio here is 2 to 1, and this is iron to iron oxide. Therefore, my moles of iron is simply going to be moles of iron oxide 0.025 times by my conversion factor. I'm trying to find out the moles of iron. Okay, so that needs to be at the top, my conversion factor, and this is obviously going to give me 0.05 moles. We are almost there. The problem is the question asked us for grams of iron. So I'm not quite there. I just have to do one small bit of math here. So we have, again, our equation here, N equals M over MR. Therefore, the mass, to find out the mass of anything, you take the number of moles and you times it by the molecular weight. Therefore, my mass is equal to the number of moles, which is 0.05 up here, times by the molecular weight. I'm going to use 56, okay, because technically it is a little bit different. It's 55 point something, but 56 is going to make our life easier. And I'm going to get a final answer of 2.8 grams of iron as my final answer. So just to recap here, essentially this entire problem is a C-type problem. The issue is we don't know whether or not to use the 6 grams of aluminium or the 4 grams of iron oxide. So I need to know which of these two values I need to use. And the answer is the limiting reagent, the reagent that is not in excess. Just to show, let me just move this down a little bit. And just to prove, I guess, in another way that we were actually right in using iron oxide as the limiting reagent. I'm going to move this down to another page just for a second. Let's go back here and say, okay, let's say I want to know if I have 0.022 moles of aluminium, which I do, how many moles of iron oxide am I going to need to react with that? Well, moles of iron oxide. This step isn't necessary. I'm just doing this to show you that you could have actually got the exact same answer in terms of iron oxide is the limiting reagent by comparing either the moles of aluminium or the moles of iron oxide. So moles of iron oxide is equal to the moles of aluminium, 0.22, times the conversion factor here, which again, if you look at the molar ratio, it's 2 to 1. I'm trying to work out iron oxide, however, so it's going to be 1 on the top, because that's the coefficient for iron oxide. If we do half of that, we're going to get 0.11 moles of iron oxide. Because remember, this here is moles of aluminium. Okay, well, if you look at this, 0.11, that's how many moles of iron oxide we need to react with the number of moles of aluminium we have in our reaction mixture. And you can clearly see that is way more than the iron oxide that we actually have. In other words, this is all going to be used up as part of this reaction because we actually don't have enough iron oxide to react with all of the aluminium. The fact that it's going to be used up entirely is, again, just demonstrates that this is in fact the limiting reagent, and therefore for all other problems we need to focus on the moles of iron oxide that we begin with. So in other words, this 6 grams here of aluminium at this point is irrelevant. Okay, we do not need that. It is not going to help with our future, or the rest of the problem rather. We can just focus on the number of moles of iron oxide. And just to reiterate, once we worked out that the number of moles of iron oxide, or iron oxide itself, was a limiting reagent, the rest of the problem was fairly straightforward. You know the moles of iron oxide, you look at the molar ratio to then work out the moles of iron. The question, however, wants the grams of iron, so we need to times the moles by the molecular weight to get a final mass of 2.8 grams.